In this lecture, we want to understand the prismatic joint, which is another common type of kinematic constraint. We will have some examples to practice, like the crank slider mechanism, an example where a slider is pinned to the ground, and a more sophisticated system with several kinematic joints. The purpose is to learn how the prismatic joints affect the degrees of freedom in a system. Let's introduce a prismatic joint. Imagine we have a rigid body which has a slot on it. And another rigid body should slide along this slot. This situation represents a prismatic joint between the two bodies. The blue slider can only move along the slot. The other 2 degrees of freedom have been taken, meaning that the slider cannot move in the direction perpendicular to the slot. Also, it is not allowed to rotate with respect to the slot. As you see here, the path of sliding might be a straight line or a curve. Just to be clear, we are talking about the prismatic joint between the blue slider and the green body, which contains a slot. But there is also another revolute joint between the slider and the pink bar, which is something else, and we should not be confused with that. Anyway, a prismatic joint can be defined between 2 rigid bodies or between a rigid body and the ground. The way we illustrate a slider on the ground might cause a misunderstanding, since you might think that the slider can leave the ground. In fact, you should imagine another barrier here, although we don't bother drawing it. As you see in these figures, another form of a prismatic joint is when a slider is moving along a rigid bar. In this case, in fact, it is the rigid bar that is moving inside the slider. Let's have an example. In this crank slider mechanism, we have 3 rigid bodies. 1, 2, 3. They bring 9 degrees of freedom to our system. We have 3 revolute joints, 1, 2, 3. Each of them eliminates 2 degrees of freedom, and we will lose 6 degrees in total. We have also 1 prismatic joint between the blue slider and the ground, which takes 2 degrees of freedom. So the degrees of freedom is 9 minus 6 minus 2, which is 1. Let's extend the formulation we already derived. The degrees of freedom is 3 times the number of bodies minus 2 times the number of revolute joints. This is what we had so far. Now minus 2 times the number of prismatic joints, because every prismatic joint also cancels 2 degrees of freedom. If we combine the number of revolute and prismatic joints, we can call their summation J1. So 3 times number of bodies minus 2 times J1. The J1 simply means the number of joints which let 1 degree of freedom. When a constraint lets 1 degree of freedom, it means that it eliminates the 2 other degrees of freedom, because in total there are 3 degrees of freedom between every 2 rigid bodies. Let's see another example. We have a link pinned to the ground and another link pinned to the first one. The second link passes through a slider, and the slider has been pinned to the ground. We remember that the degrees of freedom is 3 times the number of bodies minus 2 times J1. We have 3 bodies. 1, 2, 3. So 3. And 3 revolute joints between this link and the ground, between this slider and the ground, and between the 2 links here. And finally, a prismatic joint between the blue slider and the rigid bar. So J1 is 3 plus 1, 4. Substituting in the formulation, 3 times 3 minus 2 times 4, 9 minus 8. The degrees of freedom is 1. Last example, before I finish this lecture. This time, let's start from the ground. We have a slider on the ground. We have a link pinned to the slider. We have a rigid bar pinned to the link and also pinned to the ground. A slider moving along the rigid bar. Another link pinned to the slider and also pinned to the ground. The degrees of freedom is 3 times the number of bodies minus 2 times J1. We have 1, 2, 3, 4, 5 bodies. So 5. And 1, 2, 3, 4, 5 revolute joints. And 2 sliders here and here. So J1 is 5 plus 2. I mean 5 revolute joints and 2 prismatic joints. So 7. Substituting, 3 times 5 minus 2 times 7. 15 minus 14. The degrees of freedom is 1. Okay, that's all about the prismatic joint. In the next lecture, we will talk about the rigid joint, when 2 bodies are rigidly welded to each other.